Hi guys, today we're going to talk about the unit circle and circular functions. First, let's define what a circular function is. The following functions are defined for any real number s represented by a directed arc on the unit circle. So a unit circle is used in trig, and it is a circle with a radius of 1 with a center at the origin. So in the unit circle, our trig functions are defined as we see here. Sine of s is y, cosine of s is x, tangent of s is y over x, and then we have our reciprocal functions. Cosecant of s is 1 over y, secant of s is 1 over x, and cotangent of s is x over y. Now, before we start using these circular functions, let's talk a little bit about the unit circle. Now, if we were in the classroom, I would have you get a paper plate and fold your paper plate into sections. So if you want to pause this video and go grab a paper plate, then you're more than welcome to do so. So if you have a paper plate, I would have you fold it in half, and then fold that in half again, which would give you a quarter of a circle like this. And then if you fold that in half again, then it would break up your plate or your circle into 8 equal sections. Now in degree measure, we know that if we start here at 0, to go all the way around would be 360 degrees, and halfway around would be 180 degrees. We're going to talk right now about radian measures. In radian measures, we start here again, so if we start here at 0, if we go halfway around, that is 1 pi. And then if 1 pi is halfway around, then all the way around would be 2 pi. Now, if halfway around is 1 pi, we know that halfway would be half of a pi. So that would be pi over 2. And the other side of the circle, halfway, would be 1.5 pi's, or 3 over 2 pi, or 3 pi over 2, however you want to say it. Now, back to the top part of the circle. This is broken up into 4 parts. So all the way is 1 pi, so this would each be a quarter of a pi. So this would be pi over 4. This is 2 pi over 4, which would reduce to pi over 2. And this is 3 pi over 4. 4 pi over 4, of course, would reduce to 1 pi. Then that makes this 5 pi over 4. This would be 6 pi over 4, but that reduces to 3 pi over 2. And this is 7 pi over 4. And then 8 pi over 4, of course, would be 2 pi. So these measures are all just breaking up our unit circle into fourths. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So let me go ahead and just write the degree measures so you can see how they're related. Okay, so we know again this would be 0 degrees. Then a quarter of the way, that would be 45 degrees. Halfway around, or a quarter of the way around, would be 90 degrees. This would be 135 degrees. As we said before, halfway around is 180 degrees. This right here would be 225 degrees. This is 270. In this spot, it would be 315 and then all the way around is 360 degrees. So that would be our unit circle broken up into 8 sections. Okay, now if you were to fold your plate in half and in half again, where you have the quarter of a pie, if you take that quarter and fold it into thirds, so if you would fold 1/3 into the middle and then this into the middle, and you break that one section up into thirds, then that breaks our unit circle up into 12 parts. All right, so let's mark up our unit circle as it's broken up here. Again, we start, let me write this in blue again. We would start at 0, and we're talking about radians. So we know that halfway around is pi, all the way around would be 2 pi. Then our quadrantal angles, this would be pi over 2, and this is 3 pi over 2. Now, if we break up our pi, remember 1 pi is just halfway around. It's broken up into 6 parts. So, the first mark would be pi over 6. Then the next one would be 2 pi over 6, but 2 over 6 reduces to 1/3. So that would be pi over 3. Then 3 pi over 6 reduces to 1/2. 4 pi over 6 reduces to 2 pi over 3. 5 pi over 6 doesn't reduce. 6 pi over 6 would be 1 pi. 7 pi over 6 again doesn't reduce. 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 would reduce to 5 pi over 3. And then 11 pi over 6 doesn't reduce. And then 12 pi over 6, that would be 2 pi. So now we just broke up our circle into 12 parts. And it goes up by sixths, which is hard to say. And again, we just reduce when we can reduce. So now let's put in our degree measures. Let me erase this so I have room. Okay, let me change my colors. So again, this is 0 degrees. Now, this first mark would be 30 degrees, and then 60, and then this again is 90. This would be 120. This would be 150. This is 180. 7 pi over 6 is 210 degrees. And so for all of these, all we're doing to get to each mark is we're adding 30 degrees. 30 plus 30 is 60. 60 plus 30 is 90. And we're just adding 30 degrees every time. So then our next mark would be 240. Then 270. Oh, let me put my degree marks. So this is 300, 330, and then if we add 30 more degrees, we get to 360. So all of our sections or our marks together create our completed unit circle. So this is what the unit circle looks like with all of the sixths and fourths marked on our circle. Now each one of these marks on the unit circle has a measurement, And I'm going to go through a way to easily identify what the measures of those marks are. So the first thing I'm going to do is I'm going to mark up some sections of the circle. Okay, we're going to call these our short marks. Then we have our long marks or distances. So these are going to each of these sixths, so the pi over 6, 2 pi over 6, 3 pi over 6, well, no, hold on, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and so on. So all of the sixths, not the quadrantal angles. So these marks right here, or the corners of these sections is what I'm referring to. Okay, so on all of those, we have an x and a y value. We have an x and a y value for each one of these marks. So if we look at our lengths of our sections, if you'll notice, all of our sixths have these two angles. All right, so for the short guys, that would be the angles that measure 1/2. Let me put this back in here. Okay, and then for the long guys, those would be the angles or the distances that are square root of 3 over 2. So if you'll notice, all of these have those angle measures. They just change order, and some of them are positive and some of them are negative. Now, remember, the way that you find a point on the Cartesian coordinate system is we do our x and our y. So of course x is going to go first and then y is second. So all we have to do is when we get to that point, we see this is our x value. Our x value is long, right? So our x is the square root of 3 over 2. And then our y value to get to that point is the short guy. So that's 1/2. Okay, so if we go to pi over 3, on our x value, that's short. That's a short distance. So it's 1/2. And then to get up to our y value, then that's a long distance. That's square root of 3 over 2. Now, those are in the first quadrant, so both of those were positive. If we go over to the second quadrant, then our x values are going to be negative and our y values are positive. So if we look here at 2 pi over 3, to get to my x value, that's a short distance. So it's negative because we're going to the left, negative 1/2. And then my y value is a long distance, so it's square root of 3 over 2. And we do the same thing for all of the different values. The short distance is 1/2, the long distance is square root of 3 over 2. Let's just jump down to this one right here. Okay, so to get to this point, to get here, we would go x and then y. My x is short, so my x, and it's going to the right, is positive 1/2. But my y value is long, and it's going down, so it's negative square root of 3 over 2. So that's how we do our all of our sixths. And then all of our quarter values, the pi over 4, 3 pi over 4, and so on, all of those have the same values. We'll call those the medium lengths. That's square root of 2 over 2. So if you'll notice our x and our y, the distance is the same going from our x value and our y value. They're the same in both directions. So our x and our y are both going to be square root of 2 over 2. It just depends what quadrant it's in as to which one is going to be positive or negative. So of course over here in quadrant 3, both of them are negative because we go to the left and down. So it's just negative square root of 2, negative square root of 2 over 2, negative square root of 2 over 2. And that's how we find the values for all of our angles in the unit circle. So now let's work with those angles. Example number 1 says to find the exact values of these trig functions. And the first one they want us to find is the sine of 3 pi over 2. Now, if you'll remember our when we first started discussing these, remember that the sine of our angle is the y value. So the sine of 3 pi over 2, they want to know what the y value is in 3 pi over 2. Okay, so 3 pi over 2, remember, is, let me go up a little bit. 3 pi over 2 is this right here. So they want to know what sine is of 3 pi over 2. So sine is my y value, so that means that my sine is going to be -1. Okay, then cosine of 3 pi over 2, that would just be the x value of that same angle. So the x value of 3 pi over 2, we know, is 0. And then tangent of 3 pi over 2, tangent is y over x. So that would give me -1 over 0, but we can't have 0 in the denominator. That makes it undefined. Okay. Now we're going to find each exact value using the specified method. A says to use the unit circle to find the exact values of cosine of 7 pi over 4 and sine of 7 pi over 4. Okay, so let's go back up to the unit circle. All right, so let's find where 7 pi over 4 is. Okay, so if we look on the unit circle, 7 pi over 4 is kind of covered up. It's right here. So remember, all of the angles that have the fourths in it, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, those are always going to be the square root of 2 over 2's. But 7 pi over 4 is in the fourth quadrant. So cosine is my x value. Cosine is going to be positive square root of 2 over 2. And then sine is negative. It's negative square root of 2 over 2. Okay, for B it says use the unit circle and the definition of tangent to find the exact value of tangent of -5 pi over 3. So our definition of tangent tells us that tangent of an angle is y over x. So let's look at -5 pi over 3. Now this is negative, so we haven't talked about the negative radian measures, but remember it's the same as in an angle measure. If it's negative, instead of going counterclockwise around the unit circle, we're going to go clockwise around the unit circle. All right, so let's look at the unit circle. -5 pi over 3. Oh, hold on. Okay, so this is positive 5 pi over 3. If we went around the circle, this is 5 pi over 3. So we have to go -5 pi over 3, which means we would start out here and we would go around to this point. So this would be -5 pi over 3. Now, to get the tangent, we would do sine over cosine, or y over x, which would end up being square root of 3 over 2 over 1/2. The 2's would cancel and we would just get square root of 3 over 1, which is the square root of 3. All right, C says use reference angles and radian to degree conversion to find the exact value of cosine of 2 pi over 3. All right, so to convert this from radians to degrees, Remember we used the little formula r over pi is equal to d over 180? So we would take the 2 pi over 3, divide that by pi, and that would equal d over 180. Well, the pi's would divide out, and we're left with 2/3 is equal to d over 180, but then we would cross multiply that 180, and that would give us our degree. So that's 360 divided by 3, so our degree, our equivalent degree would be 120 degrees. I'm not sure if we've talked about reference angles, but a reference angle is the acute angle that is in standard position with the terminal side of the x-axis. So if this is 120 degrees, let's pretend like this is quadrant 1, quadrant 2. 120 degrees would be right here. Well, the acute angle that's formed with the x-axis would be this angle here. So the reference angle would actually be 60 degrees. This would be a 60-degree angle because it takes 60 degrees to get back to the x-axis. All right, so we know that if that's the case, if this is 120, we know that our circle gets divided up into 3 sections. If that's 120, then we would have 135, 150. Okay, so this is my short guy on my x-axis. So we know that that would be 1/2 for my x. This distance right here, this is short, this is long. Okay, so my x is the short guy, so that would be 1/2. But we're going to the left, so it would be a negative 1/2, which is a whole long way to go around to find that exact value rather than just thinking about your unit circle. So it's a lot quicker to learn your unit circle, find out which ones are the 1/2s and the square root of 3 over 2's and the square root of 2 over 2's, and then be able to find the exact measure of those. All right, find the exact value of s in the given interval that has the given circular function value. All right, so all this is saying is they want us to think about a particular section of the unit circle. So in this first example here, we are thinking about the section of the unit circle between pi over 2 and pi, which would be the second quadrant. So in the second quadrant, what trig functions have a sine of, or what angles have a sine of 1/2? So remember that if we're in this section of the pi, we know that if it were a quarter of the way, then that would be square root of 2 over 2. So we know it's got to be one of these sixths. Okay, so sine would be my y value, so I need the y to be the short one. So it would be this angle right here, and that angle on the unit circle that has a sine of 1/2 would be 5 pi over 6. Okay, for b, we're going between pi and 3 pi over 2. So that means we would be in the third quadrant. Okay, so if we are down here in this third quadrant, again, since this is not square root of 2, since this is not square root of 2 over 2, it's not going to be that quarter angle. It's going to be one of the sixths. So to get tangent of square root of 3, remember that all of our angles are either 1/2 and positive or negative 1/2 or square root of 3 over 2. So to get tangent is y over x. So it would have to be in this order in order for tangent to be square root of 3, because if I put the y over the x value, the 2's would cancel and that would give me square root of 3. So I need to figure out, and of course if we're in the fourth quadrant, they're both going to be negative, which would of course make tangent positive. So which one of these two, either 7 pi over 6 or 4 pi over 3, would have these values? So this means that my x needs to be the short one and my y needs to be the long one. So it would be this value right here, which is 4 pi over 3. All right, and then this says for C, whenever the angle is between 0 and 2 pi, so that's not limiting us to a particular quadrant. That would be the whole unit circle. So where on the unit circle is cosine negative 1/2? Okay, so first of all, for cosine to be negative, excuse me, our x values need to be negative, so that means we would need to be either in quadrants 2 or 3. That's where our x values are negative. Okay, so then for our x values to be negative, again, this is not a square root of 2 over 2. This is a 1/2, so it's not going to be the quarters, it's going to be the sixths. So where are our x values? 1/2. So that means a short guy, 1/2 is short. So if we have these sections of our unit circle, it's going to be these two guys right here that have an x value of 1/2. So where is that? So if we look at that, this would be 2 pi over 3. And then this one would be 4 pi over 3. So we have two answers for this one.